Yes. That's again. Oh, so she did my CA. You have to ask her how I ask questions. I'm very quick. Okay. Okay. Do not underestimate the level of creativity I have. Okay. I have to be real creative because my daughter is 7 years old. Is more creative than me. It's killing me, man. And some of you are as creative. Okay. Question number 2. I think you guys are good. Okay. Question number 3. Are you okay with question number 3? What do you mean no? Okay, I will. If question number question number 3 is one of those. Okay, question number 3, you cannot memorize the. Okay, if you can memorize the function, hallelujah for you. If not, you have to derive from what? First principle. Are we clear? So how to derive from first principle? So in order to do question number 3, so the good thing about question number 3, that function has been given. Okay, I was thinking, don't give you that function. Okay, that's kind of evil of me. Okay, and I'm not Dr. Evil. Okay, so the function over there is given. So the first part is sketch and label. So all you need to do, all you need to remember is this. Okay, all you need. So you have to label this clearly. Okay, you have to label this clearly. So this is your x. On the x-axis is omega t. Okay, if you label your graph correctly, you get 0.5 marks each. Okay, then you have, no, you don't draw this first. Then you have a value over here. Then you start drawing this. Okay, so you call this your what? So over here, this is equal to pi, and this corresponds to your peak time. And then when you put over here, this is your rise time. The distance from here to here, this is your overshoot. And this point over here, this is your first overshoot. Okay. And this point over here, this is equal to your 3 pi. This is pi over 2. Okay. And then you have a certain percentage. This is your x, your certain amount of your XSS. Okay. And then you can label down here. This is your TS. Okay. You label all this. I think you can get, I can't remember now, is it 3 or 4 marks? Okay. You label all this. Right. Straightforward to label, yes or no? Right? Not difficult at all. Yes. Yes. Not necessary, it's just arbitrary. So as long as you label TS the furthest one, you get marks. As long as you label TS just anywhere towards omega T, it's just a sketch. Okay. You don't put TS in between the peak time and the rise time. You get what I mean? Okay. As long as you know that it's on the extreme drop time. Okay. So with this, all you need to do, the next thing is you know that when t is equal to 0, x is also equal to what? It's equal to 0. Okay. So from here, you put in the function x as a function of time is equal to e minus zeta omega nt bracket c1 cos omega t plus by c2 sine omega t, and this is plus xxs. Before you go any further, you have to know the response like this is because of what? Now you have a spring and you also have a what? Damper. Okay, and this is only possible for what? On the dam system. Okay, this is only possible for under dam system where you have a what? X-axis. You want a very refined x-axis up to 2%. Okay. So from here, the first thing that you do, right? The first thing that you do is we are going to substitute x is equal to 0 when t is equal to 0. Okay, into the function. So x, so this is equal to 0. So this is equal to C1 plus by XSS. Okay, so C1 is equal to minus XSS. So from here, you just put the function again, E minus zeta omega nt. So this will be equal to minus XSS cos omega t plus by C2 sine omega t plus by XSS. Okay. So the next thing that we ask ourselves, so the question asks us to determine what? Question asks us to calculate the percentage of overshoot. Okay. I can't remember the percentage of overshoot equation. But the percentage of overshoot equation can help you determine the subsidence ratio also. Okay. So these two are related. Okay. So these two terms are related. So we know from the diagram, overshoot occurs when what? When omega t is equal to what? Omega t is equal to pi. So therefore, omega is equal to pi over t. So we're going to substitute omega. Oh, sorry. No. You're going to substitute t is equal to pi over omega, because the variable on the right-hand side is a function of what? It's a function of time. Okay, so that's a function of time. So from here, you can write out x as a function of pi over omega. So this will be equal to E minus zeta omega n multiplied by pi over omega. And then this will be equal to C1 or minus XSS minus XSS cos omega bracket pi over omega plus by C2 sine omega pi over omega close bracket plus by XSS. Okay. So we know that this is equal to 0. This will be equal to 1. So the X in terms of pi over omega, this is equal to E minus zeta omega n pi over omega. And then you have your minus XSS and then plus by XSS. So finally, minus XSS E minus zeta omega n pi over omega plus by XSS. So from here, minus, sorry, this is minus, I do apologize. This is minus 1. So this will be plus, this will be what? Plus. Okay. So from here, what we are going to do now, so this is equal, what we have derived is the overshoot magnitude. Right? So this is the steady state. Okay, this is the steady state. And this formula over here is the overshoot. Okay, or the overshoot from steady state. Okay. So you can rewrite this function for a bit more. XSS E minus zeta omega n multiplied by pi over omega n square root of 1 minus zeta squared. Okay, plus by XSS. So this you can cancel your omega. If you don't do this step, it's fine. Okay, your answer will also be the what? Be the same. Okay, if you don't do it, it's fine. Okay, your answer, when you put in your formulas, your final answer will also be the what? Be the same. Are we clear? So this is equal to XSS. I'm going to distract a bit. Alexandra Wu, come and see me before the term. When the tutorial end. Yes. Yes, omega over here is equal to omega n 1 minus zeta squared. Yes, all these are omega d. It's natural. There you go. You got it, you know. Okay, there you go. I'm so happy when you can see the light, you know. Minus zeta pi square root of 1 minus zeta squared plus by XSS. So the percentage overshoot is equal to XSSE minus zeta pi divided by 1 minus zeta squared over XSS times by 100. There you go. You're good to go. Okay. So the next one, we ask for subsidence ratio. Which is equal to the second overshoot divided by the first overshoot. So this will be equal to XSS E minus zeta 3 pi over 1 minus zeta squared. Why 3 pi? Is because when you sketch this is what? 3 pi. That's it. Okay. No rocket science. Okay, no rocket science. And then divide by XSS E minus zeta. First overshoot is pi. Right? Square root 1 minus zeta squared. Cancel, cancel. And then this will be equal to E minus zeta 2 pi square root 1 minus zeta squared. Subsidence ratio. Okay. And the last one is ask you to find what is the 2% what? Steady state. Okay. Now, I know this is just formula. So if let's say you calculate your zeta wrongly, okay, I'll say again, let's say you calculate zeta wrongly, you won't get 0 all the way, you get what I mean? We just use the zeta. So for example, 1 mark is for calculating zeta.